Alright guys, welcome back. Let's see how we can solve another question from the dynamics. And we have a 50 kilogram crate that is projected along the floor with an initial speed of 6 meter per second at x equal to 0. So we can see the x in here, and the coefficient of kinetic friction is 0.4. So we have the coefficient, and we need to calculate the time required for the crate to come to the rest, and also the corresponding distance x travel. So as always, we're going to start with the free body diagram. So obviously we have the weight of this crate in here. Let's just show it in here. So we know it's 50 kilogram, and for finding the weight we need to multiply mass by acceleration of gravity. Since all the units in here are SI units, so it's going to be 9.81 meter per square second. So that's the weight. We have the normal force that is applying from the ground to the box, and also we see that the box is moving to the right, so the friction has to be in the opposite direction. So that's our friction. Can show it with Fk, which is basically the mu k times n. And this is pretty much all the forces that we have, and we can just we already have x. Let's just call this x axis, and this will be our y. And we have sum of all forces in x direction equals to mass times acceleration in x direction, and we're gonna have the same story for y. Again, mass times acceleration in y direction. So as we can see, the box is not gonna move along y-axis, so no acceleration, which means this will be equal to 0. And here we have the weight, which is mass times acceleration of gravity, negative n, is equal to 0. So our normal force here is basically mg. But for x, we're going to have a different story, because we can see actually the box is moving along x-axis. So the only force that we have in x-axis is the friction force, which is to the negative direction of x. So negative mu k times n, which we figure out is mg. So we can cancel out mass in each side. So from this equation, we can find acceleration in x, which is basically mu k, which was 0.4, times the acceleration of gravity, 9.81. So 9.81 times 0.4, so negative 3.92 meter per square second. All right, so now that we have the acceleration, we should be able to figure out the distance that's traveled and also the time that it takes. We're going to use the formula that we talked about in the previous videos, to ax and s minus s0. We can also show this with x2. So since the box is going to rest at the end of this travel, the final acceleration is 0, and it starts with the initial velocity of 6. So 6 squared is equal to 2x. We figure out ax is 3.92, and the distance that we are talking about, we're just consider this 0, and this would be our x, and this should give us the travel x that the question is asking us. So basically 6 squared, or 36 divided by 2 times 3.92. That's going to give us 4.59 meters. That's our x. And if we want to find the travel, we have v is equal to v0 plus at. So our a would be the a that we have for ax. As we talked about, the box is going to rest at the end of this travel, so the last or the final velocity is 0. So 0 is equal to initial velocity was 6. Negative ax was 3.92 t, and from here you can find t, which is basically 6 divided by 3.92, and that's going to give us 1.53 seconds. And the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.